Hello everyone, welcome to the solution of LeetCode problem 70 named climbing stairs. In this problem, we are given a staircase with n steps, and at first we are in the position 0 and we can jump either one step or two steps from our current position, and we have to tell in how many distinct ways can we reach into the top. Let's understand the example by using a graphical representation. Here, in the first example, the n is equal to 2. That means we are given two stairs. At first, we are in the position 0. And according to the problem statement, we can jump either one step or two steps. So from position 0, we can jump to position 1 or we can jump to position 2. Now we can reach either position 1 or position 2. Suppose now we are at position 1. So from position 1, we can jump one step, and by doing so, we can reach position 2, or we can jump two steps. In this case, we will be out of bound. So this is not possible. So from position 1, we can jump only one step. So we can see that there are only two ways available to reach into the top position, which is from position 0, we can either directly jump two steps and move to the top, or we can jump one step and move to staircase 1, and from stair 1 we can jump another step. So here we can clearly see that there are only two ways to reach position 2 from position 0, which is shown in different colors. Now let's analyze the second example. In this example, the value of n is 3. That means we have 3 stairs. The top position is 3. So from stair 1, we can jump either one step or jump two steps. And by jumping one step, we can reach position 1. And by jumping two steps, we can reach position 2. Now, suppose we are in the position 1. From here, we can jump directly two steps and reach to the top. Otherwise, we can jump again one step and reach to the staircase 2. Now, we are in the staircase 2. From staircase 2, we can jump one step and reach to the top. Otherwise, we can jump two steps and go out of bound, but we cannot do this, so it is restricted. Now let's understand in how many distinct ways we can reach position 3 from position 0. At first, we will jump one step and reach staircase 1, and from step 1, we can also jump one step and reach staircase 2, and from staircase 2, we will again jump one step and reach staircase 3. So this is one possible way. Now let's find another. It is possible that we can jump two steps and reach stair 2, and from stair 2, we will jump one step and reach to the top position. So this is another valid way. Now we have found two ways to reach top, and now let's see if we can find another or not. Here from 0, we can jump one step and reach position 2, and from position 2, we can directly jump two steps and move to the top position. So we have clearly seen that there are exactly three distinct ways we can reach from position 0 to position 3 by jumping either one step or two steps according to the problem statement. Now we have understood the problem clearly, and we have to determine what is the intuition behind it. We have to determine which category this problem actually belongs to, and finally we have to reach to an optimal solution. Now let's see what we can do. Now let us try to reach staircase 4 and try to understand the intuition behind this problem and determine in which categories this problem actually belongs to. Now we have to reach staircase 4. At first we are at position 0, and according to the problem statement, we can jump either one step or two steps from each step. So from position 0, we can either reach position 1 by jumping one step, or we can reach position 2 by jumping 2 steps. Now, from position 1, by using 1 jump, we can reach position 2. And by using 2 jump, we can reach position 3. And from second staircase, we can reach stair 3 by using 1 jump, and stair 4 by using 2 jump. Now we have already reached 4 in one way. Now from stair 2, we can reach stair 3 by using 1 jump and reach stair 4 by using 2 jump. So we have already reached 4 here and here. Now again, from stair 3, we can reach stair 4 by using 1 jump and stair 5 by using 2 jump. And again, from stair 3, we can reach 4 by 1 jump and reach 5 by 2 jump. But we cannot go 5 because we cannot go out of bound. So we don't have to explore this kind of solution. So we don't have to reach 5. Now from stair 3, by using 1 jump, we can reach stair 4, and by using 2 jump, we can reach stair 5. Again, we don't have to reach stair 5 because it is out of bound. Now, let us understand in how many distinct ways we reached stair 4. This is one way. From 0, we can jump 2 steps, and from 2, we can again jump 2 steps. This is another way. This is another way. And this is another way. And this is another way. So we clearly see that there are 5 different ways we can reach stair 4 from stair 0. Now, as it is a DFS solution, the time complexity of this problem is big of 2 to the power n, because from each node we have to take 2 decisions, and the height of this tree is n. So the time complexity of trivial DFS solution is big O of 2 to the power n. Now let's find in how many ways we can optimize this solution. Now let's analyze this tree in a reverse way. Actually, we are trying to reach stair 4 from stair 0, but by jumping 1 step, our problem is in how many ways we can reach stair 4 from stair 1. And from 1, by jumping 1 step, we will reach stair 2. And our problem is now that in how many ways we can reach stair 4 from stair 2. So there is a repetitive problems, and we can say that this problem kindly belongs to dynamic programming, because one of the feature of dynamic programming is a repetitive sub-problem. Again, let's understand another crucial point. At first, we are in the position 0, and by jumping 1 step, we can reach position 1. And our problem reduced into in how many ways we can reach staircase 4 from position 1. From position 1, we will reach position 2, and our problem now reduced into in how many ways we can reach staircase 4 from position 2. So we can clearly see that there are 2 different ways. One is this and another is this. Now, when in the DFS call, we will explore the right subtree, there is a clearly repetitive problem, because from these 2, we have to check in how many ways we can reach staircase 4, which is exactly similar to this. And also, there is another similar problem here. The problem is in how many ways we can reach stair 4 from stair 3. So there is a repetitive sub-problem. Now, let us try to reduce the time complexity of trivial DFS solution. At first, from staircase 0, we will reach staircase 1, then we will reach staircase 2, and we will reach staircase 3. And we know that from stair 3, there is only one way to reach stair 4. by using one step jump. So we know the answer of this subtree, and we can cache this answer, or we can store this answer temporarily, because when the DFS call, when we will reach into this tree, we don't have to explore the subtree again. We will only get the value from the cache. Similarly, when we explore in how many ways we can reach stair 4 from stair 2, we don't have to actually explore this once more, because we will only use the cached value of this tree. So we don't have to explore these nodes. Again, if we know in how many ways we can reach stair 4 from stair 3, we don't have to explore this tree once again. So we don't have to explore 4 and 5. Now we have clearly see that we have reduced the number of DFS call, and we only have to explore this portion of the tree, which is roughly big O of n. So here we will see that it is possible to reduce the time complexity from big O of 2 to the power n to big O of n. Now let's analyze this caching mechanism by using this example. In the previous discussion, we have seen that the original problem divided into the many sub-problem. And in one situation, from going 0 to 4, we have to check in how many ways we have to reach 4 from 3. So here we can tell that if we initially stand in the top position, there is only one way, which is by default to reach the top position. And from position 3, we can jump one step, or we can jump 2 steps, but we cannot jump 2 steps because it will go out of bound. So from position 3, we can reach position 4 by only one distinct ways. These two are the base case. Now, from position 2, we have to check in how many ways we can reach position 4. And by using one jump, we can reach position 3. But we have already known in how many ways we can reach top position from 3. So we don't have to calculate it once again. And from 2, by using 2 jump, we can reach position 4. So this is actually the DP. Now we can tell that we can reach top position 4 from 2 by adding these two variables, because by using one jump, we will reach position 3, and by using 2 jump, we will reach position 4. So from position 2, we can reach to position 4 by using 2 ways. Now we have to check in how many ways we can reach top position from staircase 1. From staircase 1, we can jump either 1 step, or we can jump either 2 steps. But we have already known in how many ways we can reach top position from staircase 2 and staircase 3. So from 1, we have to add those values, which is presented in index 2 and index 3, which is 2 plus 1 is equal to 3. So here we can say that there are only 3 distinct ways we can reach top position from staircase 1. Now from stair 0, we have to check in how many ways we can reach to the top position. By using one jump, we can reach stair 1, and by using 2 jump, we can reach stair 2. But we have already known in how many ways we can reach top position from stair 1 and 2. So we have to add these two values, which is 3 plus 2 is equal to 5. So we can say that there are 5 distinct ways we can reach from 0 to the top position. Now, as we see that this is a typical Fibonacci problem. For each iteration or for each position, we are adding the previous two values. So we can see that this is a typical Fibonacci problem with an alternative problem definition. This is kind of interesting because in the real world interview, we have to determine in which category the problem belongs to, how can we solve the problem, and what is the best approach or best complexity to solve this problem. In this solution, we have seen that traditionally, if we visit all nodes, we have to use DFS and the time complexity will become 2 to the power n. But if we use memorization and do not explore the repetitive graph, the time complexity will roughly become big O of n, which is a great improvement. Now, let us understand the code. This is a typical Fibonacci code. At first, we are given a function and the top value of the staircase. We have taken a dp vector and we have insert 2, 1 because of the base condition. Now, for each I in between 2 and n, we have to add the previous two values, which is dp of I minus 1 plus dp of I minus 2. And at last, we have to return the dp of n. Now, let us understand the time and space complexity of this problem. The time complexity of this problem is big O of n because we have to iterate from a staircase 2 to a staircase n in the worst case. And the space complexity of this problem is big O of n also because we have to take a vector which size is roughly n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.